Good time of day to you, ladies and gentlemen, and welcome to the fourth lecture of this course, which is actually a continuation from the previous one. Today we are going to further discuss flow control in Python, and in particular for loops, while loops, and several concepts associated with them. Before we begin, a bit of motivation. Why do we need loops? Well, loops enable us to easily define repetitive code in an effective manner. For example, if we wanted to print numbers from 0 to 100, previously we would need to manually enter those, and while that would be tedious, it's still feasible. But what about 1,000 times? 10,000? A million? Well, very quickly we realize that there is a need for us to define repetition in our code, and that is where loops come in. Loops enable us to specify characteristics and rules for code repetition, depending on our needs. First, let's learn about for loops. For loops enable us to iterate over a sequence, any sequence, but in this example a list, and they have the following syntax. We start with a for keyword, which tells Python's for loop is to follow, then a variable, in this case I, but it can be named whatever you like. This refers to the current item we are working as, and we can refer to it inside our for loop as seen here. Then in keyword, pretty self-explanatory, and the sequence we are working with. In this case, that's a list which we defined on previous line. Then we put double dot, just like in an if statement, and start coding inside the for loop on the next line. So everything with the same indent below this for loop is gonna be part of it. A very simple example would be to iterate over a list and print out each of its elements. And let's do that now. Let's comment out the next example so it doesn't confuse us. So what happened is we said for I in fruit, I refers to each element in the sequence fruit, print I. So what it did is it went over our sequence, our list, and for each of its elements, it printed the element: apple, banana, citrus, and durian. And that's exactly what was printed. And we can do whatever we want in our for loop. We can say print that plus a word apple is a fruit. And let's try running that. And it printed apple is a fruit, banana is a fruit, citrus is a fruit, durian is a fruit. So basically, what a for loop does is it repeats the code underneath a for loop for each item inside the sequence that we have provided it. But what if we don't have a sequence? What if we want to do something n number of times? Well, that's actually when a range function comes in. It's the one I commented out previously. And let's comment the previous example. So what the range function does, it returns a list, a sequence of numbers from 0 to 1 before the one defined inside the function call. So range 5 would actually return us a list 0, 1, 2, 3, 4. And it would work exactly as the previous example, but now we are iterating over numbers. So if we run this, it will display 0, 1, 2, 3, 4. Let's do that. 0, 1, 2, 3, 4. And now that we have numbers, we can use them for whatever we like. So, for example, if we didn't like iterating through our list in this way, we could iterate through our list using indexing. Print fruit I. And that would actually give us an error because there's only 4 elements in our list. So let's do it like this and comment out this line. Fruit is not defined. It says because I commented out our definition of our list. Let's try again. And now it printed apple, banana, citrus, durian, but this time instead of referring to that using an I variable of our for loop, we got the information using indexing, using the I variable, which is in this case is a number 0, 1, 2, 3, and 4. There are a few more things we can do with our range function. For example, if we didn't want numbers from 0 to a certain number, but from 5 to 10, for example, we could do that by giving 2 arguments to the range function. So if we want number from 5 to 10, we would actually do 5, 11. and let's print the numbers so that we know that that's exactly what we returned. 5, 6, 7, 8, 9, and 10. And the third thing you need to know is if you want numbers that are not spaced equally, that are not spaced one in between, you could actually give three arguments to the range function. And the third argument would be the steps in which you would be walking. So if you run this, we get 5, 7, and 9. So 5 plus 2, 7 plus 2, 9 plus 2, 11, but 11 is the number where we stop. So we don't go any further. But if we put 12, 11 would actually be printed. You get the idea. And now let's have a look at while loops. While loops have the following syntax in Python: while, open brackets, true statement, capital true, double dots, and the insides of our while loop. So the true statement works exactly how we learned it in an if statement. We say while something holds, the code inside the while loop will execute. So if I do while true and I do print hello, it will keep printing hello until I stop the program, because true will always hold. Let's comment out our for loop stuff and run our code. So as you can see, it keeps printing hello because true always holds. In this situation, if you want to stop the execution of the program, you would press Ctrl+C. It will give you an error that the code was stopped before it finished, but it would actually never finish because true would never become false. We don't have any logic in our programs that would change true to false. And if you do it while false and run our program, nothing would happen because the insides of the while loop would not execute, because the true statement inside our brackets evaluates to false. So obviously we can implement a more complicated logic. If a number is smaller than 10, print hello, and let's define number to be 0. And if you run it now, it will again be infinite, because number 0 is less than 10 and it's always less than 10. Let's stop the execution of the program. But if we add number equals number plus 1, we will see that our program actually stops, because in each iteration of our while loop, our number is incremented by 1. So initially it's 0, 1, 2, and eventually it will get to 10, and this true statement will no longer hold, and our while loop will stop executing, and we will carry on with our code. I will quickly rewrite this. In Python, we would actually use a plus equals operator to do the incrementing. So it's just a more concise way of saying do number equals whatever is stored in number plus 1. And let's make sure it works. Yes, it does. Our number is incremented by 1 each time. The next concept we're going to learn about is the break statement. So what the break statement does is, once we reach that line of code that says break, it exits the loop we are currently in. So if we were to write the break statement right here and run our code, it will print only one hello. Why does it happen? So line 12 executed, our while loop started, number is equal to 0 and it's less than 10. Yes, so our while loop starts. We printed hello, we incremented number by 1, and then the break statement happened. Break means exit our current loop and carry on with the code. That's why, despite number being equal to 1, we only got one hello printed. If we have several nested loops, while inside a while, inside a for, inside something else, break would only break us out of the loop we are currently in. If you're in 3 nested loops, it will not break you out of all the loops. So be careful when you are using that. But break basically allows you to break when you want. In this situation, we break straight away. But if you used something like an if statement, if number equals to 5, then we break. And let's run our code. You can see that hello was printed 1, 2, 3, 4, 5 times. So in while loop happened 5 times, each time number was compared to 5, and when it was equal to 5, break happened and we exited our while loop. Obviously, we would want to use our while loop for something more complicated than printing hello a few times. So for example, if you wanted to collect a bunch of information from our user, we could use an input function inside our while loop. We can put any Python code inside our while loop to make it repeat the number of times that we want, and we can break whenever we want. So basically, as I always say, imagination is your limit. Another keyword we're gonna learn is continue. What continue does, it says stop with current cycle of our loop and go to the next one. So actually, let's write it here. So in each iteration of our while loop, hello will be printed, and then continue will end this current cycle and start the next one. So can you guess what's going to happen when I run the program? We get an infinite sequence of hello agains. Why is that? Well, that's because continue, let's stop the program. Continue ends the current cycle of our while loop before the number gets incremented. So the number never actually gets incremented, right? And if you move continue out here, and if we put continue at the end of our while loop, it's basically the same as not putting it there in the first place, because our while loop, the cycle of our while loop ends there. And as we expected, our cycle stops. Again, you would use it in a certain scenario, like using an if statement, where you want to end the current cycle if a certain condition is met. And that might differ depending on the scenario you're currently working with. Those are all the new concepts we're going to learn in this lesson. And now let's have a look at how we're going to utilize everything we have learned thus far to write something a bit more useful and a bit more interesting. So in this example, we have wrote a game where the user has to guess a number between 0 and 100. And if they guess correctly, they will be congratulated. So let's run our code first to see how it works. It asks for our guess, 4, 6, 2, and if we guess correctly, it will say congrats. So how does it work? We define the number we are looking for, we define how many tries the user has, and we do our while loop that will carry on until tries left is greater than 0. Inside our while loop, there are three things that will happen. First, we will ask the user to make a guess and store their answer inside a guess variable. And if the guess was correct, we will print congrats and break out of our while loop. And if it's not, we will decrease the tries left by 1, minus equals 1. So that's decrement by 1. And we will start our while loop again, as long as our true statement holds. You will notice one thing here we haven't learned yet. I'm using the int with my guess. That's because by definition input taken from the user from the terminal is treated as a string, and in order for us to compare it with a number, we need to convert it to an integer, and that's how we do it. Now we can extend it a bit. So if the user's guess was not correct, we can give them a hint. If guess greater than number, we can say lower, else higher. This way the user will be given a hint whether the numbers they have guessed just now is higher or lower, whereas the numbers they're looking for is higher or lower than the ones they guessed just now. So let's run it. Let's do 4. It gave us an error because, again, we are trying to compare a string with an integer. So let's change it back to an int. 4 higher, 77 lower, 45 higher, 56 lower, and 55. Congrats. And if you run it again, and if you do 5 incorrect guesses, our program will terminate because we have run out of tries. So that's just a simple example of how you can combine everything we have learned so far to build more complex programs. And obviously, it's a very simple example. You can build upon it. You can nest more loops. You can build longer programs. It's up to you what you build with it. But I hope this example was helpful to you. This concludes this lesson, and I'll see you next time when we are gonna learn functions.